Thanks. Okay, well, I'll dive right in for the sake of time, and thank you so much for the introduction, Emily. Okay, so deep learning-based pose estimation tools like DeepLabCut have recently made it possible to automatically track a wide variety of animal behaviors with a high degree of accuracy. But to understand the cognitive and neural basis of behavior, neuroscientists need tools to manipulate an animal's environment or neural activity in relation to behaviors that are being tracked. So we want to provide closed loop feedback based on an animal's posture in real time. And to accomplish this goal using the DeepLabCut toolbox, experimenters need to first feed images from a camera to a DeepLabCut network, and we want to be able to estimate the pose fast. We also are going to need to perform some post-processing steps on the DeepLabCut estimated pose. So this might include sending or receiving commands from an external device. So we might want to turn on an optogenetics laser based off of what DeepLabCut outputs are telling us. And another thing we might want to do would be to predict the animal's future posture to counteract for delays. So we want to be able to provide feedback at exactly the time the animal is exhibiting our behavior of interest. And so we might want to predict what the animal is going to be doing a little bit into the future to deal with the delay from actually estimating the pose in DeepLabCut. So for this talk, I'm going to introduce some new software tools that will hopefully make this process simple for everybody. So in our workflow, the first step is to export a trained DeepLabCut model using the new model export tool, which is in the main DeepLabCut package. And next, to run a real-time DeepLabCut experiment, this network must be loaded and prepared to analyze images. And so we've written two software packages that will do this. The first is a simple Python package called DLC-Live, which is just designed for this purpose only. So it just loads networks and analyzes images. And the second is a new Bonsai plugin that allows users to load a DeepLabCut network and analyze images using a camera feed from within Bonsai. So importantly, within both of these tools, we provide convenient methods to downsize or crop images for faster performance. So DeepLabCut is much faster with smaller images. And so these methods allow you to record video with large images so you can save that extra detail for offline analysis, but you get the speed boost from analyzing smaller ones. And then finally, we need a method for feeding images from the camera straight to DeepLabCut. So Bonsai already takes care of this part, but we've also developed two additional packages that use DLC-Live for real-time pose estimation. First, a standalone GUI, which we're calling the DLC-Live GUI. And we've also integrated DLC-Live into the behavioral control software AutoPilot. This is a relatively new software package that leverages some very cheap hardware to run operant conditioning behavior across kind of a whole room of boxes. And then lastly, DeepLabCut-Live was designed to make it really easy to integrate this functionality into new software packages. So it should only take a few lines of code to add real-time DeepLabCut to your software applications. So really quickly, just wanted to point out that we've tested this DeepLabCut-Live package on a variety of systems. So to see the complete results, please check out our preprint on bioRxiv. But generally, if you're looking to optimize performance, then we highly recommend using NVIDIA GPUs, such as the Titan RTX. If you're trying to run this on a tighter budget, then we can recommend these NVIDIA Jetson machine learning focused embedded systems. They achieve pretty good performance, so it should be fast enough for most applications. And then depending on how sensitive your application is, you might be able to even get by with just a conventional laptop. So we've tested it on a couple of different systems with just CPUs. All right. And so once we have the animal's posture in real time, we need to identify the behaviors of interest and control an animal's environment or stimulate or inhibit neural activity. And so using this DLC-Live package, this is easily achieved using a DLC-Live processor. And so this serves as just a callback function. So every time DeepLabCut estimates the pose of an animal, the processor is run to perform any computations or operations you desire, and there are few to no constraints here. And so since we developed this software during the pandemic with little to no access to our usual lab resources, I'm going to demonstrate this with a little experiment on my lovely research assistant, Izzy. So Izzy loves to jump up for treats. And so what we're going to do is we're going to turn on a little LED in the corner here whenever she jumps up. And so I want to point out that it's really simple. It only takes about 15 or so lines of code to implement a processor to do this. And so once we have the animal's posture in real time, I'm sorry. So you can see pretty clearly here that the system will reliably turn on the LED, but we have one small issue is that no matter how fast we can run this experiment or how fast we can estimate the pose, we're always going to run into some delays between when the animal is exhibiting behavior and when we can actually send a control signal. And so to counteract these delays, we can try to predict the future pose of the animal. And so here we're going to provide a demonstration that uses a Kalman filter to estimate the position, velocity, and acceleration of all tracked body parts in real time. And we're going to use this information to predict where each body part will be. And so again, I want to point out that this can be implemented with only a few lines of code, and the base Kalman filter is provided here on GitHub in the DLC Live package. And so without forward prediction, you can see here that we were about 70 milliseconds, it took us about 70 milliseconds to turn on the LED from the first frame in which Izzy's paws were above the level of her shoulder blades. But when we use this forward prediction module, you can see that we're much, much closer to turning on or off the LED right around the time that she was actually exhibiting this behavior. And so kind of that's the gist of what these new software tools can offer. And so in closing, I'd just like to thank Mackenzie and Alexander Mathis' labs at EPFL, and in particular, Sebastian and Jesse in Mackenzie's lab, and then also these institutions for providing their support for this work, and also Emily and the Neuromatch Conference. And so now I can open up for questions and discussion.
All right, thank you, Gary. That is the first Neuromatch talk I have seen that featured a dog. And so I think our first question is, can we just see more videos of your dog? And while we're waiting for audience questions, I'll ask the same question that I asked Felipe, which is, what is your impression of having to score behavior from motor impairments? Like, do you think that you could, for instance, just label frames of control animals and then still be able to capture those, same points on a, let's say, Parkinson's animal model or Parkinson's human or anything like that? Or do you think you would actually need to train individually on those two different kind of motor types?
So I think it's really going to depend on what these individual frames look like. So DeepLabCut is choosing these labels based off of like the single image that you provided. So it's only using basically like whatever statistics it can pull out from that individual frame. And so if like the individual images, if kind of the configuration of limbs and the positions of the body are relatively similar between the videos you're taking of a healthy or control animal versus like a motor impaired animal, then it should work just fine. But if your motor impaired animals exhibit some weird kinds of movements, so like for example, when training this network to track Izzy, I had to label a ton of frames to get this to work successfully because there was just really huge variety in the frames. So like have to label kind of like the entirety of a jump sequence, and I'm going to have to label that jump sequence in all different parts of the room, because if Izzy's facing in a different direction or something, then the configuration of these limbs is different. And so it's kind of a novel image for the DeepLabCut. And so I think it's kind of like you want to make sure that you're labeling like one image from kind of the whole complexity of the behaviors that you're going to capture.
Okay, that makes sense. Yeah, I'm hoping to see DeepLabCut used on to make more kind of automated behavioral phenotyping. Like I have scoring for things like some scoring for motor impairment outside of things like gripping tasks is largely just kind of scores, and it can be somewhat subjective. So I'm excited to see kind of the capability of DeepLabCut to track animals through kind of motor impairments that are unusual, especially seizures. Being able to classify seizures behaviorally would be really nice, but seems also like it would be quite a challenge once you get into like full tonic-clonic seizure range, and the possible position of any part of an animal is literally anywhere in the video camera space.
Yeah, I mean, you wouldn't have to label like one of absolutely everything, but you definitely like you're going to need to get like a good range of things. And so DeepLabCut also provides some tools, so you can label a first set of images, train the network, and then you can easily pick out the ones that DeepLabCut is failing on. So it provides kind of this confidence measure that will tell you like I have no idea, like kind of where so you can kind of pick out these low confidence frames where it either like isn't sure where a body part is, or it thinks that the body part is missing from the video. And so it's usually easy to identify where it's failing and to fix those specific parts.
Great. All right, we have another question from our favorite question asker, Melissa Franch. Thank you, Melissa, for all of these wonderful questions. She says, thank you, Gary, this is great. When you label different parts of the animal at different orientations, you keep the label the same, correct? Meaning there is always one label for left paw, but you will train the network on the left paw for many orientations?
Correct. So if, for example, I'll just keep talking about Izzy, my favorite subject. So in like this image right here, like you can see, so like the right paw is further from the camera at this point, but if Izzy was turned around in the opposite direction, then the right paw would be kind of the closer limb. And so that's always going to be the case, is always going to label the body parts for exactly what they are, and you can train them. It's even possible to train one DeepLabCut network on multiple camera views. And so like because it's just taking the raw image and just spitting out labels based off what it has learned from that raw image, it doesn't even necessarily have to be the same camera view.
Neat. I actually had one question about the part you mentioned at the end, the Kalman filter. Could you go into a bit of detail about that to help out those of us like me who like kind of have an idea what a Kalman filter is, but not quite?
Yes. So I think the most important part of it is really just like for the forward prediction aspect is really just measuring the position, velocity, and acceleration. And so we just do that by taking, so like the position is what DeepLabCut spits out as like the position on the latest frame. The velocity is the difference between this frame and the frame before, and then the acceleration is the difference between the velocity measured on this frame and the velocity measured on the previous frame. So once we have those three values, then it's a quadratic approximation. So we're literally just saying, so we're using this acceleration and velocity and just kind of extrapolating forward to predict like where do we think it's going to be based off of like its current position, its rate of change, and the change in the rate of change. So the Kalman filter aspect is just like a small trick to eliminate noise. So if you just take those raw values, then especially in the derivatives, so when you're calculating velocity and acceleration, any noise that's in the position, which is like, so if you have noise in the position, it's not too big of a deal, but the noise in the position can get really amplified. So if you have like, if the actual position of the limb has stayed the same, but because of just, random noise, it thinks that it moved down quite a bit, then when you make your forward prediction, that noise is going to dominate the prediction, because it's like the model is now going to think that like it's kind of moving, its velocity is moving downward, but it's really staying the same. And so what the Kalman filter does is just like a technique for real-time Bayesian filtering. So it just uses kind of the expected uncertainty or like some level of noise that it expects in these measurements to get a better estimate of position, velocity, and acceleration, and therefore giving you a better prediction.
Thank you. All right, while we had that answer, we have three more questions that just came in rapid succession. So let's see if we can get through all of them in like 4 minutes. Okay, first one from Joseph Lushinger. I hope I'm not butchering that too badly. Great talk. For more complex behaviors, there are a number of options for ethogram identification. Can you speak to how/if ethograms could be incorporated into DLC-Live?
Yeah, so just for a quick answer here, the processor object is super, super flexible. So all it has a function called process, which just takes in a DeepLabCut pose. And so you can implement whatever your ethogram algorithm is. It could be anything. It could even be another deep neural network. And you can use that pose, feed it into like your whatever algorithm you're using for your ethogram, and then you can figure out like which behavioral state the animal is in, and then do some sort of triggering or control external hardware based off of that. And so because like you can also save a history of poses, so that's kind of how we implement the Kalman filter, is we save like the last couple of poses, and so you can just implement it solely there. And so just it shouldn't be too difficult as long as you have that code already written.
Great. Then we have one from Alejandra Regla Vargas, who says, can you speak a bit more on sub-zero latency feedback? I'm not sure I've wrapped my head around what that means.
So I guess it's almost like a little bit of a joke. So the goal is to have zero latency feedback. You want to be triggering something exactly when the animal is exhibiting behavior, but there's a little bit of noise there. So, and also this experiment, we handicapped ourselves by using like a $20 webcam and very cheap hardware and things. And so we weren't super precise. And so when we were shooting to get zero latency feedback, sometimes we were a little bit early. So we were actually like turning off the light 13 milliseconds on average before Izzy completed her jump sequence. And so that was, I think we could get a lot more accurate if we had just used nicer hardware, or if we had a behavior that was a little bit easier to train with a faster network.
All right, and then we have one last question from Melissa again, who asks, do you have any experience using DeepLabCut to track moving animals from a camera that is not moving? So for instance, if you strapped a GoPro to Izzy, and then you wanted to track another dog that Izzy was playing with.
I don't have experience with this, but there is no theoretical reason why it would fail. I mean, some things to consider are motion blur. So if you have a camera that's moving on a dog, then you're going to need a pretty low exposure to make sure that there's not motion blur so you can get good images. But otherwise, DeepLabCut should be able to be trained to track whatever you train it to track. I think that's the biggest thing, is like whatever training images you give to DeepLabCut, that's what it's going to learn how to do. So as long as you give it the appropriate training images, then it should be able to learn to track it.
Neat. All right. Thank you so much, Gary. And thank you everybody in the audience for so many wonderful questions.